In mathematics, G2 is the name of three simple Lie groups. They're Lie algebras, as well as some algebraic groups. They are the smallest of the 5 exceptional simple Lie groups. G2 has rank 2 and dimension 14. It has two fundamental representations, with dimension 7 and 14. The compact form of G2 can be described as the automorphism group of the octonion algebra, or, equivalently, as the subgroup of SO that preserves any chosen particular vector in its 8-dimensional real spin or representation. History. The Lie algebra, being the smallest exceptional simple Lie algebra, was the first of these to be discovered in the attempt to classify simple Lie algebras. On May 23, 1887, Wilhelm Killing wrote a letter to Friedrich Engels saying that he had found a 14-dimensional simple Lie algebra, which we now call. In 1893, Elie Cartan published a note describing an open set-in equipped with a 2-dimensional distribution, that is, a smoothly varying field of 2-dimensional subspaces of the tangent space, for which the Lie algebra appears as the infinitesimal symmetries. In the same year, in the same journal, Engels noticed the same thing. Later it was discovered that the 2-dimensional distribution is closely related to a ball rolling on another ball. The space of configurations of the rolling ball is 5-dimensional, with a 2-dimensional distribution that describes motions of the ball where it rolls without slipping or twisting. In 1900, Engels discovered that a generic antisymmetric trilinear form on a 7-dimensional complex vector space is preserved by a group isomorphic to the complex form of G2. In 1908, Cartan mentioned that the automorphism group of the octonions is a 14-dimensional simple Lie group. In 1914 he stated that this is the compact real form of G2. In older books and papers, G2 is sometimes denoted by E2. Real forms. There are 3 simple real Lie algebras associated with this root system. The underlying real Lie algebra of the complex Lie algebra G2 has dimension 28. It has complex conjugation as an outer automorphism and is simply connected. The maximal compact subgroup of its associated group is the compact form of G2. The Lie algebra of the compact form is 14-dimensional. The associated Lie group has no outer automorphisms, no center, and is simply connected and compact. The Lie algebra of the non-compact form has dimension 14. The associated simple Lie group has fundamental group of order 2 and its outer automorphism group is the trivial group. Its maximal compact subgroup is SU times SU. It has a non-algebraic double cover that is simply connected. Algebra. Dynkin diagram and Cartan matrix. The Dynkin diagram for G2 is given by its Cartan matrices. Roots are G2 although they span a 2-dimensional space, as drawn. It is much more symmetric to consider them as vectors in a 2-dimensional subspace of a 3-dimensional space. One set of simple roots, for is WEYL, Coxeter group. Its WEYL, Coxeter group is the dihedral group D6 of order 12. Special holonomy G2 is one of the possible special groups that can appear as the holonomy group of a Riemannian metric. The manifolds of G2 holonomy are also called G2 manifolds. Polynomial invariant. G2 is the automorphism group of the following 2 polynomials in 7 non-commutative variables, which comes from the octonion algebra. The variables must be non-commutative, otherwise the second polynomial would be identically 0. Generators. Adding a representation of the 14 generators with coefficients a, n gives the matrix. Representations. The dimensions of the smallest irreducible representations are 1, 7, 14, 27, 64, 77,182, 189, 273, 286, 378, 448, 714, 729, 748, 896, 920, 1224, 1254, 1547, 1728, 1729, 2079, 2261, 2926, 3003, 3289, 3542, 4096. 4914, 4928, 5005, 5103, 6630, 7293, 7371, 7722, 8372, 9177, 9660, 10206, 10,556, 11,571, 11,648, 12,096, 13,090. The 14-dimensional representation is the adjoint representation, and the 7-dimensional one is action of G2 on the imaginary octonions. There are two non-isomorphic irreducible representations of dimensions 77, 2079, 4928, 28652, etc. The fundamental representations are those with dimensions 14 and 7. Vaughan described the unitary irreducible representations of the split real form of G2. Finite groups. The group G2 is the points of the algebraic group G2 over the finite field FQ. These finite groups were first introduced by Leonard Eugene Dixon in Dixon for odd Q and Dixon for even Q. The order of G2 is Q6. When Q2, the group is simple, and when Q equals 2, it has a simple subgroup of index 2 isomorphic to 2A2, and is the automorphism group of a maximal order of the octonions. The Janko group J1 was first constructed as a subgroup of G2. Reintroduced twisted re-groups to G2 of order Q3 for Q equals 32n plus 1, an odd power of 3.